So hi guys, I'm Parampreet Singh and we are doing MLP sessions like this term, and till now we have done 5 sessions, okay, and covered till week 3. Some little part of week 3 is left which we will cover today. Okay. So like I'm recording all these sessions and uploading the recordings, the videos in my YouTube channel here. Like you can subscribe to it for the like session recording. Okay. uh,
Okay.
so also like just one thing I want to share. Yesterday I gave a talk in like in a local meetup in my city, so this is the recording of that talk, so you can watch it like if you want. It is on Python one liners, like for the list comprehensions and the lambda functions as well as conditional expression. So yeah, that's it. Okay, so let's start. Till now we have like covered like we have done 5 sessions, right? uh, okay, so these 5 sessions we have done. Okay, so these are the 5 sessions we have done, and now we have like 6 session today, which is on feature engineering and feature scaling. Less of feature engineering, like more on feature scaling we will do. Okay, so before that, do you guys like, how many of you have uh, covered the week 3 content? You can just give a thumbs up or speak up if you like.
Just half of the week three,
Okay,
only four
so
lectures.
no worries. After like today's session, complete week 3 content will be covered. Okay, and we will like also look and I will also like give you a glimpse of week 4 also. Week 4 will be gonna be like very interesting because now we will study algorithms from week 4. So let's start. Okay, so the font is clear. Font size, is the font size clear to you all?
Yes, it's better.
Okay, so I'm just using the same notebook which we had in previous session. Like we are doing the follow-up steps, right? So today we will mainly do like feature engineering and feature selection. So also like we will don't worry, we will create the pipeline and all that stuff also. So let's start. First let me run all the like needed steps. Feature engineering and features. So here like the first and foremost basic step is like to import all the required libraries. Okay, so here I have some libraries, then loading the data, then doing the, then we have done some basic EDA. After that, like we did the transformation, mainly like we did the data pre-processing stuff. We converted the, like we first imputed the missing values. We have done like transformation, column transformation of categorical columns into numerical columns using both like one hot encoder and ordinal encoder. Okay, for like all this detailed stuff you can watch the session 5. Okay, session 5, there I have done all the stuff in detail and also explained what each of these functions and strategy, basically how it like do the thing. So let's start now. So here before the modeling stuff, let me just write here feature, I guess fifth one. Yeah, fifth one, feature engineering. So don't worry, I'll do a little bit feature engineering only because like I know a lot of you might want uh, a lot of you are not familiar with the dataset. So yeah, just before like starting, let me tell you, we are using This we are following this competition, Titanic machine learning from disaster, and we are obviously using this data. Okay, so you can join this competition for your practice also. Okay, like to do the MLP, to cover the MLP concepts in like practice, and also for the MLP project if you want to do the practice and all that stuff. Okay, so let's start. In feature engineering, the first step is to look into the data once. Okay, so here we have this data. Okay, not the x train. So this is the data we have. Here we have a lot of columns like this. We have done some. This is mainly the data pre-processing. Like we have converted the sex column and embarked column into one hot encoded. So now we have this column SIB, SP and PRs. Both of these columns represent the family relation. So SIB represents sibling and SP represents spouse, and same for the PRs. Like PAR represent the parents and CH represent children. So like if you see these two columns, extrain SIB dot value counts. We have okay. Okay, zoom out. So now it is clear. Is it visible now? Amit, is it visible? Um,
Visible.
okay. So like in SIB SP we have these many like features. So we can also like a little bit feature engineering. We can do kind of like map these to some external columns as well. Like we can create some new columns based on them. Okay, so if we see the data, like about the columns, the data set contains brother, sister, stepsister, spouse, husband, wife. So 1, 2, 3, 4, 5, 6. So we might have 6. Okay, so we have like 6. Okay, we have 6 types of values here, right? From 0 to like 0, 1, 2, 4, 3, 8, 5. 3, 4, 5, 6. Okay, 7. Let me just copy paste it once from here. Then we'll get some idea. Just like I want to just show you in feature engineering what we mainly do. So okay, sorry. SIB, SP. Okay, so we have all these relations here: brother, systems, step brother, step sister, and in spouse we have husband and wife. So we can basically map these features, map these values to some kind of new columns also. Like uh, what we can do here, what is the shortcut key for commenting? For normally like in Kaggle notebooks and all, we just use hit control and slash. So this will like help us to comment the code. Same thing works for multiple columns as well. Like if I select them and do control slash, it will comment it. Okay. So yeah, here like we have various values. So for the sibling we have brother, sister, brother and stepsister. Then we have husband, wife. So 6 values are here. Okay, so here we have more values. 3, 6, 7. Okay. So like it's not that much clear if we are okay. 3, 4, 5, 6. Okay, so if we like look into the PR column, here we have like 6 values. Okay, sorry, 7 values, where first 2 values are like mother and father, then daughter, son, stepdaughter, stepson, and some children travel with a nanny, so therefore PR for them, so it is written. So what we can do is we can create new features here, like how let's say or there like we have information where the value for PR is 0. Those, like, they are the children and they are traveling with a nanny, so we can create a new feature based on it, right? What we can do is, like, wherever we have PR key equals 0, extreme, okay, so these are all the features. Sorry, this is the filter data set where we have all the childrens which are traveling with a nanny, so we can create a new feature based on them, like uh, how, okay, let me show you once. Extreme, okay, child with nanny, and not like this. Okay, before doing this, what I can do is I can simply create a function here, lambda, where I'll represent like I'll have each row, and if the value is 0, if x equals 0, then what I'll do is I'll just simply write 1, else 0. So it will give me all the, like, it represents here we have a column which is of binary form of 0 and 1, and here 1 represent that those children are traveling with the nanny, so we can create a new column based on it, like a child with nanny, something like this. Okay, and same thing we will do for the other data set also, like for the xvalid and test data frame. So here we have the test gf and test gf. So if I run it, now if we see our data frame, we have a new column named child with nanny. Okay, so this is how, like, we can do the feature engineering and all the stuff. Same thing, like, we can check like, are they parents? Okay, so for, let's say, to identify whether they are parents or not, let me just confirm it once. With the help of which age we can check whether they are parents or not. So if I just simply filter out, let's suppose 5. Okay, okay, so the age here is this, for the 1, age is this, and so, okay, um okay, there is not much clarity about all the stuff. So okay, let's suppose all the parents we have, they are in they basically are in 4, 5 and 6. Okay, so what we can do is we can create another feature based on it. How? Let's see. So park, if I write here and apply lambda, what I'm doing here is I'm creating like a new feature where I'll represent if there are, like, parents, then it represent 1. If they are not parents, if they are children, then it represent 0. Okay, so like, I'm just doing if xn uh, for 1, if xn, let's say 3, 4, 5 and 6, I'm just doing for all these 3, else 0. So here, like, now I will get a new, okay, let me check the value counts once. Yeah, so here I'll get a new column where this 7 represent the children we have, and same thing we can do opposite for also, because, like, we have more children. So let me, like, run it. Yeah, so this data, like, from the here we have created a new feature which basically represents if they are children, then the value is 0, sorry, then the value is, okay, yeah, then the value is 1, else if they are parents, then the value is 0. So with this, let me create a new feature based on this data. This is children, and now I'll copy this for the other data set also. X valid, and here also X valid, and here test GF, test DF. So here like I have created a new feature as well. So if we look into the column, yeah, so here now we have a new column which represents is children. So if they are children, then the 1 is there. If not, then they have 0. Okay, so this is like just an example which I want to show you. Okay, so there like a lot more stuff we can do here. Feature engineering we can do, like based on the class and fare we can predict average fare price for each class. Should I show you like, okay, uh, should I show you another like way of doing feature engineering?
परम स्क्रीन
Yes.
आपने जो अभी कॉलम ऐड किए वो ठीक है, वो समझ आ गया, बट वाई क्योंकि ये समझ नहीं आया.
Okay, so feature, okay, sorry, I forgot to tell about the concept of feature engineering. Feature engineering क्या है? It's a very important concept in machine learning. Basically in like before the modeling stuff. In feature engineering, what we do is we create new features based on the existing features. Okay, so let me show you one example. Let me open the like this whiteboard once. So let's suppose should open it here. Yeah. So let's suppose okay. Okay, so let's take this example only. Okay, so here we have a P class and a fare column, right? So P, okay, let me select it. So sorry, I have to zoom it now. This, so we have P class and fare column. So what P class okay, feature engineering में हम क्या करते हैं, हम like we look into the existing features, we see like what these features are. So here we have some information about all the features, right? So here for the P class we have the information that it represents the socio-economic status. So like 1 represent upper, then 2 represent middle, then 3 represent lower. Okay, so इससे हमें एक idea मिल सकता है like those who have the P class one, they must be paying higher fare compared to the second and third, right? So okay, so this P class is same as the berth we have in trains, like the first first AC, second AC, sleeper class, and general. Generally, like in train we have higher fare for the first AC, right, compared to second AC and third AC. Am I like right? So
Okay,
the same thing we have here, right? If we see, so okay, we can get an idea of it also if I like just show you directly here. Okay, so the X train P class, let me copy this, and we have these 3 classes here, 1, 2, and 3. Okay, so now if I like create a group by data, group by object of it, train dot group by P class, and then if I like find the fare and check the mean. So here you can see for the upper class, like for the P class 1, their average fare is 87, and for the P class 2 their average fare is this, and same for the third. Okay, so with this like we are deriving a new information which we can represent like as average fare of each class, right, of each P class. So this is kind of a new information we are deriving from the like we are extracting from the existing information. So this is what is feature engineering. In feature engineering, we use the existing features and we create new features based on the features and information provided. And how it helps in modeling, like sometimes we have way less features in our data. So like here earlier we have only 6 to 8 features. Like if we create more features, then our model will like when we uh, train our model, then it will like use various features, and based on like various features we may get a better score and a better prediction. That's basically like our model will get more ways to like learn the data, right? If we have more number of features, then our model will get more number of ways. So this is what is feature engineering. Let me show you like one another example. Let's suppose you are having a house data. Okay. In house data, like we are having some columns, let's say number of bedrooms. Okay. Same like we have for number of, let's say okay, number of bathrooms. Okay. So these two columns we have. Okay. In our house data, and we have to predict price based on certain columns, and these like we have some more columns also. Let's suppose say size, and there is a target label this price, and let's say we have a boolean column as well, is balcony, like they have a balcony or not. Okay, so based on these two columns we can create a new feature which says like total number of rooms, right? We can just sum up these two features, and we can create a new feature based on it, and this is what called known as feature engineering. So it eventually helps us in the modeling stuff. I mainly like whenever I have some data and I created some models, whenever I did the feature engineering, I always get the better score compared to the earlier one data. So that's why we do the feature engineering. So is it clear to you all?
Yeah, clear. And in many cases, we reduce the feature.
Yeah. Okay.
It's
So
also under the feature engineering, you know?
that is under the feature selection. Okay.
Okay.
So
In
like we
feature
reduce,
engineering, mostly,
we
yeah,
create
in
new
feature,
features, we transform the features also. Okay, and we create new features also. So
in
like
under the feature engineering.
right. And like let's suppose I have created a new feature named total number of rooms and size, then I can create a new feature based on these two features also, which we can say like average size of a room, right? I can create a feature like this. Am I right? Average size of a room, because I have size of the complete house
Yeah.
and we have total
If
number
we
of
have size
rooms,
and the total number, then we can find the size of the
right?
room.
Average size.
Yeah.
So same way we can do a lot of feature engineering. It's just like okay, so for doing the feature engineering we need the domain knowledge. Here comes like a very important stuff in data science. Whenever we have some data, we first we first should research about the data, like the field it is of. Let's suppose if the data is of, here this data is of real estate, right? So uh, this feature might be useful, like so we get an overview like average size of a room and average size of a bedroom, in fact. So whenever user buys a house, they mostly see like how much the room is, right? How much their kitchen is, how big their kitchen is, and how big their bedroom and all the other rooms, right? So this is like how can we get all this information? This all information we can get from like we need and this is called domain knowledge. So here we have the real estate domain. So uh, we need the real estate domain knowledge so we can do a research generally जब भी हम कोई product बनाते हैं. And when we have the data, we first do the domain like we first do the research on the domain we have. Okay, the data of domain we have. We research which features are relevant and which features are not. Let's suppose I have a example. Let's say we are predicting whether a patient has heart disease or not. Okay, so it is a classification problem. One for yes and zero for no. and we have some feature, let's say chest pain, okay, heart rate, and so on and so forth. So here we can create another feature name, let's say. So there are, like, I have created a project on heart disease predictor, so I know there are 4 types of chest pain. So I can create a, like, average heart rate of for each chest pain. Like if we have a type 1 of chest pain, then their heart rate might be different, right, compared to the other one. So like are we doing the right feature engineering or not? For that we have to do the we need domain knowledge, okay.
Yeah, yeah.
Okay,
Clear.
so
Very much clear. And
yes.
in feature engineering, we only work on this increase or take more information from the feature.
Yes.
And other than this, also some other work we can do under
No,
this
we mainly
thing.
create new features, okay, in feature
Mm.
engineering. Then there is a step comes which is called feature selection. In the feature
Okay.
selection, like we select
Yeah.
some features based on various criterias, like various threshold we have,
Yeah.
and mutual
Yeah.
information, and a lot of other things, okay.
Yeah. Yeah. It is different from
Right.
feature engineering.
Yes,
Yeah.
yes,
Okay.
and that
My
step should be
focus
done
on
after.
that it. Yeah. My focus on feature engineering.
Mhm.
This is only one task under this, or any other maybe one, two, three
Mhm.
more tasks. Okay.
So Jagan Mohan is
Yeah.
asking if training
We can
accuracy,
continue.
is it allowed? See, if training accuracy is 1 and testing accuracy is zero point 0.9, then your model might be like, it seems like overfitting, but then you can try other metrics also rather than accuracy, which are like, let's say, a precision and recall. And based on precision and recall, you can check the F1 score and plot a ROC curve. I know all this information, like you might be wondering what are all this. Don't worry, we will discuss it in further sessions, okay. uh, this might seem as an overfitting, because let's suppose in training data we have all the, like, features, let's say we have all the majority stuff as one, okay. Let me take this example. So let's say heart disease is a rare disease, right? So let's suppose if the patient we have 10,000 examples, 10,000 patient data, and out of 10,000 we have, let's suppose 9,500 of them doesn't have heart disease, and only 500 of have heart disease. So we have created a binary classification model, and that model's accuracy is 95%. So can we say our model is accurate based on, like, just the accuracy? What do you think? Can we say? If your answer is yes, then you can give a thumbs up, or no, then you can give a thumbs down. Okay, so let me clear you. We have 10K examples, and for heart disease, and as a heart disease is a rare kind of problem. So out of the 10,000 patient data, 9,500 of them do not have heart disease, and only 500 of them have heart disease. And we have created a model, and that model's accuracy is 95%. So can we say, like, our model is accurate, our model is showing us the correct information? Can we say this? You can just speak yes or no, you can even take a guess.
I think no.
Okay. Okay, so see, here we have the accuracy 95%. What accuracy does is it just check whether the uh, prediction and the true label is same or not. So like here I have the true label, and here I have the predicted labels. So it just check whether these are same or not. So when they are not same, it just like does not increment the value, and if they are same, then it increment the value. So here the accuracy might not be a good metric. Why? Because let's suppose it is only giving 95% based on this, like it is predicting uh, 0 for all the samples, okay. Because it is a rare disease, so that's why, like, 500 of them doesn't have a heart disease. So there's a less like 5% accuracy is less, okay. So here what we can do is we can use some another metrics known as, like, okay, precision, and recall. Okay, so these are some metrics which we can use. I'm not like showing you what these metrics are, I'm just giving you an overview. Precision tells like jitne bhi like the number of predictions we have done, how many of them are correct. Okay, so like predict based on the number of predictions, how many of them are correct. So like actual values and the predicted values. And recall tells like okay, so before that we have a concept of confusion matrix also. So you can like just ignore this stuff right now, but you can just get an idea that accuracy might not be the always the best metric, okay, for the problem we have. So we should
Is
use
the
other
precision
metrics.
and the recall one contains the TP and
Right,
FP? Is it
right.
the one you are talking about?
Yes, yes, yes. The true positives, false negatives. So that's why we need a confusion
Mhm.
matrix also, right? So that's why I'm not
Mhm.
going into that stuff right now. Okay. Yes, this is how like a confusion matrix look. Uh, this is I guess for the all columns we have. Okay, so let's get back into our topic. Okay, so here we have a column named P class, and we have calculated average fare of all these. So what I can do is I can create a new feature based on this column which says like average fare of each P class. So the same thing I can achieve via this function also, transform, where I'll pass the mean parameter and I'll get the mean of each column. Here just that I'm getting the mean for each of the value, only 3 values, but here I'm with the help of transform function, it is mapping their their mean value with the exact samples we have. Okay, so this I can do here, like I can just create a new feature here, average P class fare. Okay, so with this we can create a new feature, and same thing we can do for the other stuff also. Here now one thing like come which is like, as I told you, okay, test here. So as I told you in the like previous session also, we generally fit our data on generally fit only our training data, not our validation or test data. We do the transformation or of like on valid and test data based on the training data itself. So the same thing we will do here. We won't like calculate the average fare of each P class for the validation and test data. We just simply copy paste and all the stuff here. How can we do so? Like obviously the samples will be different for all this, so how can we do it? Like we can create a new column as well. Okay, so ignore this as of now. Let me, yeah, so here we get all the average mean values, right? Now let me create a dictionary of this, that will be much better. So if I write uh, so, average P class fare, and let me create a dictionary where one maps to its average value and two maps to its average fare value, and same for the third one. So here I have created a dictionary called average P class fare, and with the help of this dictionary we will map all the values. How? Let's see. So first I'll like fetch these two columns, P class and fare. Okay, then I'll use the apply function, and in the apply function I'll get both of these columns mainly, right? So if I, okay, let me just check what this is giving. Okay, so this is giving me a series like this. I have the maps function here. Okay, so map is also right. Okay, so what we can do is I have there is a function in pandas called which we can do this stuff. Let me check it once. I forgot a function name. Um, I have to map these values according to the average feature we have. Okay. No worries. Just let's ignore it for once. I'll add the sample in the notebook and I'll share it in the uh, like video description. Okay. So let's just use these only 2 new features right now. Okay. Now let's move on to the another step, which is feature scaling. So feature scaling. Now here, like okay, not the feature scaling, feature selection. Sorry. Feature selection. In feature selection, what we do is we select the features, like whichever how like what features should we use for the modeling stuff. So we may have a lot of features and we need to select some few features, because let's suppose if we have 100 or more than 100 features, then our model will take a lot of time to do the training, like to learn all the features, right? So that's why we do a step called feature selection, where we select the features based on various things. So there are like a lot of ways to do the feature selection. Let me like show you 1 or 2 of them. So for the feature selection, what we can do is generally like one thing which basically normally people do is they take the correlation. Okay, so if I do the correlation here, and if I like okay, let me do the join also. PD dot data. I have the y train. So here I'll get the correlation of all the features we have, including the target variable. Now I'll plot the correlation. So let me plot it. SNS dot heatmap, and I'll just pass it here. It will plot the correlation here. So this is the correlation you can see for all the features with respect to the target label. So here we have the target label called survived, right? So what correlation tells us is like are the features linearly independent with themselves or not. So obviously the same features are linearly independent, like p class is highly correlated with p class, and so same with the name and same with the age and same for all rest of the columns. Now we mainly in the correlation in the heat map, we mainly check for the target label. Okay, so here we have in the last, if you can see the last column here, survived. Here the darker boxes are representing they are less correlated, and the lighter columns are representing they are highly correlated. So except the survived column, because obviously that column is highly correlated is themselves. So except that column, we can check which columns are highly correlated or less correlated, and we can also see the numbers also with by passing the not equals to parameter. We can see the numbers. Okay, so here you can see this is now cluttered up. Let me just create a bigger figure of this. Big size equals, let's say, 12 by 12. Now, so yes, now you can see here we have the numbers also with the correlation. So the correlation is from -1 to 1. Okay, the range of the correlation is this. So what we can do is like here you can see the p arch column, fair column, 6 female column, and embarked C column, as well as embarked Q and is children. These columns are correlating with our feature survived. So so we can do is like we can select all these features and train our model. Let me show you like one example. Here we have this correlation, right? So what I'll do is, okay, rather than this, I'll just write useful columns, and here in the columns I'll just write the columns name which I need to select. So first I'll choose the PRs, then fair, then cabin, then sex_female, then embark C, and the same I'll do for the Q also, and then is children. So these are some of the columns we have. Okay, let's use these columns and train our model. So currently, like in normal, okay. So normally, if you see, if we do the modeling on the existing features, or by selecting all the features, we are getting the accuracy as of now, which is 74%. So let's see, if we select only these columns, should we get a better accuracy or not? So how can we select these features? I can, okay, let me create a copy of this data, that would be better. So xcopy train, which is like xtrain.copy type equals to. Same I'll do for the valid also, copy valid. X valid. Now in the xcopy and xvalid, let me only use these features. So xcopy train equals xcopy train, and I'm selecting only these columns. Okay, so I'll write here. Same for the valid also, because we will do the validation with the help of valid set. Xcopy valid and useful columns. Now let's train our model based on this. So xcopy train, yeah. This is the linear regression model. You can ignore this warning as of now. Oh, sorry. Now let's create another model, which is decision tree classifier, and run it. Now do the evaluation. So here, instead of x valid, we will use the xcopy valid because of the same number of features. Now I have the predictions here. Okay, so these are the predictions I have, and now let's check the accuracy of our models. So here you can see now accuracy is decreased rather than increasing, the accuracy is decreased. So that's why, like, okay, now the accuracy is 73. Earlier we have the accuracy of 74. So there are various ways to do the feature selection. I have just shown you a simple and a manual way to select the features. Obviously we cannot, if we have a lot of features, then we cannot write all the feature names here, right? So this is just a one way of doing the feature selection. Is it like clear to you all?
Please explain after the heat map.
Okay, so after the heat map, here you can see some features have the, like, are correlating with the survived column, right? And the features which are which are linearly correlating with the survived column, they have their correlation value in positive, like the PR, fair, cabin, and all these columns. And we are selecting only these columns, and we will train the model based on these columns only. Okay, so I am just selecting these columns, and I have trained two models, logistic regression and decision tree classifier, and I did the prediction on the validation set. And here you can see the accuracy of all these two models based on only the selected columns. So if I select these columns and do the prediction, I'll get the accuracy as 73%, like 0.73. So this is just one way of doing the feature selection. Is it clear now?
Yeah, clear.
Okay, so like there are many ways to do the feature selection.
Yeah, according to, I think in week 3 there are lots of
Right.